Okay. In theory, we're live. What is going on over there? Okay. All right. Hey, everyone. Welcome to another Monday Open Space. This is your show. I have no idea what's going to happen, what we're going to talk about. I have my guesses. I'm sure there's some things that people are going to want to talk about. Venus, SpaceX, Fermi paradox, the usual. But definitely, if you've got some questions about space and astronomy, let me have them. Throw them at me. I'm ready. Let's see. I don't really have a lot. I guess I do have a little bit of stuff to get out of the way. On tomorrow at 11 o'clock, and I apologize, I don't have the event set yet. I'm going to be interviewing the physics professor, Peter Hoyt, who writes the blog Not Even Wrong, and he's a big critic of string theory. And so we're going to be talking about string theory and the state of particle physics and where particle physics goes next now that the Large Hadron Collider has been, has done its job. It's done its one job. Where do we go now? And so we'll be talking about sort of the state of particle physics and the future of that. Next week, I'm going to be doing an interview with Chris Carr. He's one of our co-hosts on the Weekly Space Hangout, and is a extra galactic researcher. And so we're going to have a lot of interesting conversations about galaxy mergers and tidal tails and that kind of thing. So that'll be next week. So I'll put both of those events. I've got to hurry and get the one for tomorrow up quickly. So that'll show up pretty quickly, and that'll be tomorrow at 11 a.m. Pacific time. So stay tuned for that. We had a great virtual star party on Saturday night. If you missed that, we got a chance to see Mars and got to see some shots of Jupiter and live pictures of sunspots, Neptune, and then a whole bunch of really great nebulae. So lots of great stuff. And of course, more episodes of Astronomy Cast coming up and more episodes of the Weekly Space Hangout. I'm just looking at the lineup here. We've got Ralph Lorenz, who I have already interviewed, I believe. Oliver Wutas, who is he's the project manager for the Mars Express spacecraft. Ingrid Dauber, John Powell, Alan Stern, and Marie Cody. So we got lots of good interviews coming up. All right, so let's just get into it. All right, so Nancy asks, thoughts about Bridenstine leaving. Bridenstine, I'm so sorry, Bridenstine. Thoughts about Bridenstine leaving when President Biden takes office. I don't really have any thoughts about that, actually. I think, we were all pretty nervous when he took office in the first place, especially coming from a position of being fairly skeptical about climate change. That was a very, very disturbing position to have, the head of NASA have. But I think he recanted that and went on to progress NASA. I thought he's fine. I don't really okay, so what do I like? I like the amount of integration of SpaceX and commercial space. I mean, that SLS and the Artemis plans were at this kind of logjam, and it really looks like Bridenstine helped push forward more of the more clever ideas coming from outside the agency to help take some of the pressure off of trying to hit that timeline pretty quickly. You got some really clever ideas about replacing this SLS for the first launch with a SpaceX, using Falcon Heavies for some of the cargo parts, integrating maybe a Blue Origin New Glenn, not that one has ever flown yet, into the process as well. But also a lot of much smaller projects. There's a lot of tiny pieces that need to come together to be able to land on the moon, be able to, hardware, software, be able to bring stuff back from the moon. There's a lot of little parts moving. And so that all seemed like the right, I really don't think that NASA should be in the big rocket game. I really am of the opinion that they should be, NASA's job is to push the envelope, to work on the kinds of technologies that it just doesn't make sense for the private industry to work on. New kinds of propellant, new ideas, everything from NIAC and things like that, as well as a lot of the science stuff that there's just no, there's no commercial reason to build the James Webb Space Telescope, but there's a scientific reason. And so I think there's lots and lots of value in going down that direction. And it's clear that NASA had gotten snared by the law, by the fact that building the Space Launch System in the way that it was being built was the law. And I think you could see effort to try to clear that logjam and try to provide more flexibility while still accomplishing that objective. So I don't know. I think, like, if you asked me for a list of people to run NASA, I could give you a list of dozens of people who would be incredible at running NASA. So is Bridenstine the best one to do it? I don't know. I think if you're going to have an administration change, I think it does make sense to look at every part of the organization and see if you've got the right person in the job. But at the same time, I think, there's a lot of value in ideally career bureaucrats. And I know that Bridenstine went from being a politician to running NASA, but I think, for governments to work over the long term, you need to have people who are apolitical. They're doing their job. They're trying to do the best job that they can to run the government. And if you replace those people with every administration, you lose the long-term memory of your organization. And I think it's really important to be able to maintain that. So I think that, it's funny, like if you had told me that Biden is just going to have Bridenstine stay on the job and Bridenstine said, yeah, okay, I'll keep the job, then that wouldn't surprise me. And if you said, oh, Bridenstine has decided he's not going to stay on the job, that also doesn't surprise me. And if Biden said, I've got this amazing person who's going to take over NASA, that would also not surprise me. And like I said, I can imagine some people who would do phenomenal jobs of running NASA. So right now, it's all just, I don't really have much of an opinion about it. So there we go. Arjone asks, what do you think of Elon Musk declaring Mars a free planet? I think that would be a lot to take on. So if you haven't heard, in the Starlink user agreement, I think you have to agree that if you're using Starlink on Mars, then your legal options kind of require you to go to whatever is the Martian government in this case. And so what does it mean to declare Mars as a free anything? Well, currently under the Outer Space Treaty, you cannot own any part of space. And so you can't own the moon, and you can't own Mars, and you can't own Jupiter, and you can't own Europa. There are rules that you can do. You can, you can go to set up a research base on the moon or on Mars, and you can even extract resources from those places to be able to supplement your base. But if, for example, anyone else shows up at your base, you have to let them in, and you have to let them use your facilities. It's very similar to the way it works in Antarctica. And so any settlement, for example, that actually tries to survive on Mars is going to be completely dependent on Earth. And I mean, we saw this happen back in the 1700s with the United States, that in the beginning, they're dependent on England for all of their resources. And then eventually, when they're self-sufficient, they're able to cut the ties and declare their own independence. And so you will see something very similar to that. You will see that for the first however many decades, hundreds of years, Mars will be completely dependent on Earth. And so if they're going to try to, declare independence, does that also mean that they don't want any more supplies? It's pretty tough to be able to make that declaration. But if they do get to a point where they are completely independent, then I think it makes sense to say they want to be able to have some say in their own in their own laws and their own future. So I think you're just going to see it's going to be this natural thing. It happens time after time again. You're going to have them completely independent on Earth for shipments, for supplies, for everything. And then there will come this day when they are able to cut the umbilical cord to Earth, and then they probably will do so. And I hope that if and when that day happens, that people at both sides will do it in a very peaceful way. Like Canada, while the Americans back in 1776 had a very violent split from the UK, Canada in over 100 years later, it was a fairly amenable split, and we're our own nation now, but we didn't have to have a fight to go over it. So that's possible too. Let's see. K-Bear asks, are there any limits on how large or how sensitive we could make a gravitational wave detector? Will we ever be able to get down to the level of planets orbiting a star or smaller? Apologize, you heard me laugh. That's because I don't think we will ever get to that point. So right now, the current state-of-the-art gravitational wave detectors are advanced LIGO and Virgo. And at this point, they are detecting about one gravitational wave merger every week, which is incredible because before they made a series of upgrades, they were only detecting a couple a year. But the kinds of gravitational wave events they're detecting are black holes merging with black holes merging with neutron stars crashing into neutron stars, maybe white dwarfs crashing into black holes or neutron stars. The most dramatic event. And it's hard to really wrap your mind around a black hole with dozens of times the mass of the sun smashing into another black hole with dozens of times of the mass of the sun, rippling out these gravitational waves through space-time. And so we're not going to, with advanced LIGO and Virgo and even other facilities coming online, we're not going to be able to get much more powerful than that. And in fact, those facilities can't even detect the supermassive black holes because they merge too slowly. And so you get these very long period gravitational waves as opposed to the really quick ones that you get from two black holes crashing into each other, the stellar mass. So there's new plans in the works. There's a version of LIGO, and I forget the name of it. We did a video on it, but it'll have 40-kilometer long detection arms and will be much, much more sensitive. And it should be able to start detecting smaller events, more common events, white dwarfs crashing into white dwarfs. Maybe when LISA gets operational, which is, of course, the Laser Interferometer Space. I don't know what the A stands for. Someone will put it in the chat. Anyway, LISA, the space-based gravitational wave observatory, they're going to detect probably those supermassive black holes. But what they're really going to do is increase the sensitivity farther and farther out into the universe. And in the next iterations, essentially astronomers are going to be able to detect all of the gravitational waves in the observable universe. And then after that is going to be this thing called the Big Bang Observer. And that is going to be able to go beyond the cosmic microwave background and be able to detect the primordial gravitational waves that are left over from the Big Bang itself. And that is really, really exciting because right now, the cosmic microwave background radiation, which is, of course, the radiation that's given off by the moment the universe was invisible and light could escape, is more than 300,000 years after the event of the Big Bang. And so the only way, like right now, physicists know what happened earlier through math. They calculate what were the temperatures like, what were the pressures like, what was going on when the various forces started to detach themselves from one another. But there's no observational evidence of that time because you just can't see light earlier than the cosmic microwave background. But gravitational waves will. And so when that next generation, the one after LISA, the Big Bang Observer, like we're going to be into the 2040s at this point, then there should be instruments which will be able to go right to the Big Bang. And you will see the ripples of space-time as the first moments of expansion are happening. And that is a mind-bending possibility because now you will be able to directly observe how the first few just milliseconds after the Big Bang, as our universe began that rapid expansion. I can't wait. Will we ever get to a point that we can see planets? Probably not. That just a planet moving through space at the velocity the planet orbits a star is just so small compared to the amount of space-time distortion that comes from a black hole crashing into a black hole. I mean, there will be other things, like we will probably be able to see supernovae going off if they if they give themselves like a really powerful kick to one side, and other really extreme events, but it's going to be extreme events for the longest time. All right. Dr. Ed Elcott, cryptozoologist. Have you already covered the new damage at Arecibo? We're working on it for Universe Today. Oh, there you go. Public imaging array. Okay, there you go. LISA. Laser interferometer space array. Okay, sorry. Are we working on the new damage at Arecibo? So if you didn't hear over the weekend, the Arecibo Observatory in Puerto Rico, one of its main cables snapped. And, they had already been dealing with the problem of one of the support cables snapping, and it caused about $10 million of damage. And they were just in the process of requisitioning the funds to try and do this. And now one of the big cables has snapped, which is really scary because now you've got one support cable and one main cable that's broken, and more damage was done to the observatory. And we're going to have to wait a little while to find out how much damage was done. But now the whole facility is getting less and less supported, more rickety. And so if you get like a powerful storm, or you get an earthquake, or you get just forces build up on the rest of those cables, you could have something that's even more damage. So it's kind of scary right now. And I mean, Arecibo had been hovering at the edge of cancellation for the longest time. And so for it to get, 10 million here, who knows how much this other repair is going to cost. At a certain point, I'm worried that they're just going to go, we don't need to keep this observatory going, which is too bad because until before the Chinese telescope was built, the Chinese FAST telescope, it was the largest radio telescope on Earth, single dish radio observatory on Earth, and did an enormous amount of science. A lot of really great work scanning asteroids using radar as they fly by. So all of that's going to be going to the FAST telescope at this point until Arecibo can get online. But you just want more of these things. It would be a real heartbreak if they weren't able to get this repaired and operational. So I really hope they do. All right. Avi Scott and Flower, what do you think about the coincidence of the moon exactly covering the sun during eclipses? Some people claim that as evidence for the engineers. Now, when you say the engineers, are you like talking about like in the Larry Niven Ringworld Engineers sense? It's a coincidence. It's a helpful coincidence that the sun is exactly, I believe it's 80 times bigger than the moon and also 80 times more distance, but it's not perfect. And so sometimes the moon is closer and sometimes the moon is more distant. And so you get different kinds of eclipses. Sometimes you get an annular eclipse where you get this ring of fire around the moon, and other times the moon is closer and covers off the sun, and other times the earth is closer to the sun, and so you get sort of different versions of it. It's just a coincidence. And you can imagine if you like put together a list of the millions of coincidences that there could be. This is just the one that came up for us. Like, I'll give you another one. The fact that Phobos is spinning into Mars, and then in the next 30 to 50 million years, it's going to crash into Mars. And so we're here at a time when Phobos exists, which is kind of amazing. And I think the biggest one is that we are here at a time when you can even see the cosmic microwave background. That when you think about the total amount of time that's going to exist in the universe, that there will be tens of trillions, quadrillions, quintillions, a Google years into the future, we're here just 13.8 billion years after the universe began, and we're able to see the cosmic microwave background. And future astronomers won't have access to that background information in the same way that we do. And yet we missed the party of star formation, and all the really cool activity was going on billions of years ago. And we're already in the cooling down, dying universe already. So, no, it's just a coincidence. All right, let's see. Hit me with another question. Oh, see, there's some questions there that I don't like. You're asking me to do a calculation. I don't know the numbers off my head, and I apologize. So ACOG Mean is asking about white holes. Are white holes real? No, there's no evidence that a white hole is a real thing. So we did an episode on this, but the gist is that if you take the numbers for black holes, and you put in negative numbers into some of the places, then you get weird things. And one of these is this idea of a white hole. But it would require that you have various things like negative mass. So, and also another prediction is that the moment anything comes into a white hole, it instantly disappears. The white hole disappears. So just because something works mathematically doesn't mean that thing exists, especially if I'll give you an example, right? Like if you take time dilation and you want to calculate the amount of time dilation that you're going to experience as you go faster and faster, closer and closer to the speed of light, if you put the speed of light into this calculator, then your journey from your perspective is instantaneous. And if you put faster than the speed of light, say twice the speed of light, then your travel time is backwards in time. In other words, you arrive at your destination before you left, which is weird. And that's just because you're putting numbers into a mathematical equation that were never meant to handle those numbers. Now, does that mean that faster than light travel, or being able to travel at the speed of light, is possible? Only for light, not for anything that isn't light. And it's just like, yeah, you can do the math if you want. I can have negative donuts, which means that people owe me donuts, but it doesn't mean that people actually owe me donuts. It's just math. So, sorry. We talked about this quite a bit, but just this idea that science fiction takes these little scraps of interesting ideas, wormholes, white holes, faster than warp drive, faster than light travel, transporters, all this kind of stuff, and uses them as MacGuffins, which is like, the term for just a thing, a piece of machinery, whatever, to accomplish some plot point. And so we as in people who really enjoy science fiction, are just like, we're artificially fed all of this stuff. And we wish it was true. But according to the laws of physics, as we understand them today, none of these things are true. Now, maybe we will discover something that means that the laws of physics as we understand them aren't true. And we can tell that at the edges of our understanding, there are clearly, stuff that we don't understand. What goes on inside the event horizon of a black hole? How does quantum mechanics and gravity connect with one another here in this universe? We don't know the answers to these, and chances are the current theories are insufficient to be able to explain them. But it doesn't mean that any of these science fiction Christmas ideas are ever going to work. And yet there's lots of really amazing and wonderful things that are actually being done and discovered. And so we'll see what happens. All right. Oh, Ethos Hunter, have you read much Alistair Reynolds? Do you have any other good hard sci-fi authors you'd recommend? I haven't. I've got some Alistair Reynolds books that I would like to read, and I haven't read them yet. I think my wife read Alistair Reynolds. She liked them. But no, I'm reading, what am I reading right now? I'm reading a Chinese book right now called The Earth is Online, and I'm sort of building myself up to be able to read The Three-Body Problem in the original Chinese. So that's sort of where all my leisure time has been going right now. All right. A.V. Scott and Flower asked, Fraser, why do you think that Elon never talks about artificial gravity or nuclear propulsion? So those are two questions, right? Why does Elon Musk not talk about nuclear propulsion? Because I don't think a private company like SpaceX will ever get its hands on a nuclear propulsion system. Maybe in the far, far future, when Mars declares its independence and Elon Musk is able to is able to get access to Mars-based radioactive materials and build a nuclear drive. But I don't think he really cares. Like, clearly, the Starship, he feels like with chemical rockets alone, Starship, a fully fueled Starship, like refueled in space, will be able to make the journey to Mars in a short enough period of time to just deliver the colonists to Mars. And you don't really have to worry that much about going an extra month quicker. And then as it relates to artificial gravity, same thing, which is that you're only going to be in space for 3 or 4 months. We know that human beings can be in space for a year. We saw Scott Kelly do it. So we know it's possible. You don't really have to worry about the long-term effects of microgravity for a trip that's only going to take you 4 or 5 months to get to Mars. So I think his plan is to go fast. And then you don't have to have a complicated rotating thing. Now, for the Jeff Bezos future, where everybody lives in space stations and everybody knows that gravity wells are for suckers, then yeah, someone's going to need to develop some kind of artificial gravity system. But for now, it's just like that's a problem that you check off in the far, far future. And there have actually been some pretty efficient, pretty doable strategies for providing some level of artificial gravity. If not like full-time rotating ring spaceship artificial gravity, then at least something that you can get into and be spun around and be able to handle, minimize the amount of bone loss and muscle loss and your fluids jiggling around in your body. And so you can actually I've seen designs, they fit inside a 5-meter fairing. So just a standard Falcon 9 rocket would be able to hold one of these. And it's just like a tiny little centrifuge that you just get inside and it just goes around and around and around. You get 2 of them, going in reverse directions, and you maybe sleep in it, or you spend, you do your work inside this little centrifuge. And then you spend the rest of the time in microgravity. So I think the biggest issue is that we don't know what's going to happen to human beings when they get to Mars. And they're going to be trying to hang out on the surface of Mars and for years, and they're going to be trying to have children, and they're going to be trying to raise those children in this reduced gravity. Nobody knows the answer to this question. And every day that goes by that we get closer and closer to people wanting to go to Mars and do this stuff, and nobody knows what's going to happen, is, I think, starting to border on crazy. And so there's got to be an experiment. There's got to be a decade's worth of experiments to figure out what's going to happen to human beings in reduced gravity. You could go to the moon and figure it out pretty quickly and see if the moon is enough. People that I've talked to, they think that the moon is probably too low and Mars is probably okay, but we don't know for sure. So if people go to the moon and the moon is fine, then Mars will also be fine. But if people go to the moon and the moon is not fine, then we don't know if Mars is going to be fine. And so we've got to figure this out. And if we don't figure this out, then people are going to go to Mars, and then they're going to be living there, and then they're going to have babies, and there's going to be problems. So I really hope somebody figures this out sooner than later. Sergio Botero. Hey, Sergio. Any idea why testing artificial gravity in space is so expensive? It's not that it's super expensive. There have been some experiments to test this. And I was actually doing a little research, and I found a German spaceship. There's a German satellite that had a artificial gravity cylinder in it. Two parts of the mission were very successful, but the artificial gravity part, they were trying to test growing plants in artificial gravity, and it failed. And so we didn't find out the results of this, which is too bad. But there have been people kind of chipping away at this problem. And as I said, there has been a design for one that would just fit inside a standard rocket fairing. It could be attached to the International Space Station, and we would find out. There's a bigger version called the Nautilus X that's been proposed to attach to the International Space Station, a big ring that people could sit inside. And it's also been adapted potentially to be able to, the idea has been adapted to be attached to the Deep Space Gateway. But in both situations, it's a list of priorities, right? Space Launch System is siphoning money, and so you can't build a module to attach to the International Space Station or the Deep Space Gateway to be able to test these ideas out. James Webb is gobbling money, and so you can't test out these ideas. And so I think that somebody needs to test one of these ideas as soon as possible, because it is potentially the biggest stumbling block that we're facing to moving out into space in a way that's safe for long periods of time. All right. Storm D, what is the fate of the Artemis project? Will it continue in the new administration? Good question. I have not heard anybody make the case for what's going to happen with Artemis, but I can't imagine anyone making any significant changes to it. I mean, at this point, we are 4 years away from the first humans going to the moon, returning to the moon. That the contracts are already underway to build portions of the Deep Space Gateway. The Space Launch System is just about to launch, probably in the next year or so. Plus, all the other parts are waiting in the wings, right? So I think that we're going to see, and I think that NASA needs a goal. By not having a long-term goal, having to shift its focus back and forth to different ideas has been bad for NASA. And I don't think that anybody argues it to this, at this point. We know that you need a goal, you need a long-term goal, you need to stick, and going to the moon is a good goal. So keep doing that. Don't go to an asteroid, go to the Mars, go to the moon, back to Mars, back to an asteroid, just go to the moon. Well, actually, that's not, my preference is to just follow just achieve bigger and better things with every mission. Last in space longer, test artificial gravity, test out different things with life, go farther from the Earth, learn to do refueling. Like I would have a checklist of 1,000 things that I think NASA should accomplish, one after the other, and I would just move through that checklist. I always describe the Gemini program as this example where let's have 2 people go into space. Now let's do docking. Now let's do a spacewalk, right? You just run through this checklist of capabilities. And so the concept is called capabilities driven exploration. And you just go farther and you just set your goals farther and farther and farther along, continuing to build your capabilities up. That's my preferred way, because then you can't have the goal taken away from you, because the goal is always just the next thing that you're trying to do. Now we're trying to send humans to Phobos. Now we're trying to grow tomatoes in space. So now we're trying to refuel 2 spacecraft in lunar orbit, because that's a capability that we need to be able to have. So that's my preferred way. But I think but at the same time, I think that the 2024 deadline clearly had some compromises built in, a lot of hardware. Like, the thing that I liked about the Artemis mission was that you would get this new style of exploring the moon. So right now you build this, back in the 1960s and 70s, you built the Apollo, the Saturn V with the Apollo missions. You flew to the moon, astronauts got out, walked around, got back in, came home, brought some rocks. But that's not very sustainable. And so the whole idea with the Lunar Gateway is that you build this gateway to the moon where you fly to and from the gateway, just like people fly to and from the International Space Station. You attach additional capabilities to the Lunar Gateway, and then you fly from the Lunar Gateway down to the moon and back up. And then eventually you get a base on the moon. And so you've got people ferrying from Earth to the International Space Station, or Earth to the gateway to the moon, back and forth. And you're reusing all of this equipment. And it's a much more, it's like a much more stable, long-term way of exploring the moon, if that's what your goal is to explore the moon. And you can go from the Deep Space Gateway to other parts of the solar system, depending on where you put it. Now there's other people that think that you should just go straight to Mars, and that's what, I know that's what Robert Zubrin thinks, and that's what Elon Musk thinks, and I think that's fine. I mean, you can have, there's whatever plans the Chinese are going to have for their lunar exploration. You've got the Russians want to continue on with their space exploration. Europe is getting involved in lunar exploration. So it's not just all on NASA's hands anymore. There's lots of other people. Athos Hunter, as a computer scientist, what are your opinions on GPT-3? It's not just memorizing, but it also definitely doesn't understand what it's doing. So what's going on here, and what can we do with it? Wow. All right. Now, normally I wouldn't take this question, but I'm so stoked on GPT-3 that I just have to rant about it. So thank you for the question. So for people who don't know, GPT-3 is the 3rd iteration of this text system created as artificial intelligence text generation system created by OpenAI. And what they did was they essentially slurped in all of the internet and then did predictive text. So you imagine like autocomplete. But they I think they spent about $10 million. It's a ludicrous amount of compute resource was spent on getting this thing to work. And it can write documents that are very difficult to distinguish from a human being. And if you play a game like AI Dungeon, you can sort of interact with the OpenAI, and it's this really eerie thing to sort of see what the future might hold. I think it's going to change everything. I think, like, even if it isn't artificial intelligence, and even if it isn't thinking, it's going to, I already have 1,000 ideas on how I would like to incorporate something like GPT-3 into the work that we do with the universe today. Not to write our articles, of course. That would be madness. It would just like make stuff up. But imagine I could feed a very complicated research paper into GPT-3, and it could try to summarize it for us in a way that makes more sense. It could tell us the highlights of interesting pieces of news that we should look into further. So I am And the thing that's very interesting as well is that the growth, if you sort of look at the chart as it went from GPT to GPT-2 to GPT-3, it's still a straight line. It's still clearly providing a significant benefit on the previous versions. So I think it's just a matter of time till someone creates a GPT-4 and a GPT-5. And I think someone did the math on this, that we could still see about a 100,000 times improvement in the capability of GPT-3 for a reasonable return on investment, for $1 billion, somebody could run a version of it that is about 100,000 times more powerful. And it's kind of scary to think how useful that might be for humanity, or wipe us all out. So yeah, I feel like when GPT-3 came out, artificial intelligence definitely turned a corner. And I'm very sad that OpenAI has not released it publicly in the way that the whole purpose. I mean, I can see why Elon Musk left OpenAI. Like they've drifted away from the purpose of this company is to help us understand the dangers and threats of artificial intelligence. And so to then develop something that demonstrates the capability of artificial intelligence and to then not allow us to wrap our heads around it is pretty terrible. So I think they should release the code. They should release let other people build their own version and tinker with it and understand it, because the control problem in artificial intelligence is going to be a big one. We don't understand how to make these programs do what we want them to do. And this is a huge field of research that still needs to be done. There's a lot of thinking that needs to be done to be able to get us to a point that we actually can safely develop these very powerful artificial intelligences. And we're already seeing the downsides. We're seeing bias. We're seeing both human bias writ large in these artificial intelligence. We've seen them crash trading systems because they're just moving too quickly. Like, there's all kinds of risks, and we need to be able to deal with them. So I think GPT-3 is, I would say it's the most exciting, interesting thing that I've seen in the field of artificial intelligence for the last couple of years. And I'm pretty excited to see what happens next. And at the same time, I wish they would release it in a way that other researchers could get a better sense of what they did to make it happen. All right, so I know that had nothing to do with space and everything to do with existential threat and artificial intelligence, but you definitely triggered one of my biggest interests. All right. The peaceful is willing to. What do you think about the concept of cloud cities on Venus and rather settling there than Mars? Venus sucks. Venus, I joke about this all the time. We should just push Venus into the sun and be done with it. But of course not. We shouldn't push Venus into the sun. It's got raw, valuable resources. It is a scientifically fascinating place that will tell us about the history of the solar system and how runaway greenhouse effects can happen. So, all right, we'll keep Venus around. And of course, I'm sure you all know, that if you get to about an altitude of about 50 kilometers on Venus, the atmospheric pressure and the air temperature are about the same as Earth. And so you could walk around on the outside of Venus in nothing but with a respirator to be able to breathe air. And air from Earth is a lifting gas on Venus. And so you could have a balloon that's floating around in the cloud tops of Venus. But that's terrible. Like, I'm sure you'd have 1 minute where you'd be standing on the railing of your Venusian cloud city or your airship, and you're looking out across the cloud tops, the horrible sulfuric acid cloud tops, and going, wow, I am on Venus. And then what I wouldn't do to just stand on dirt, climb a mountain, hold a rock. You're just going to be stuck. It's going to be how it's felt being during this the pandemic, and you're kind of stuck inside your house. It's like that. Mars, at least you can escape. you can escape from your tunnel every little while and soak up some cosmic rays, trying to avoid cancer for a little while before you have to scramble back down into your tiny little cell. Do I sound like I'm just I'm a realist. So no, I don't think that we'll ever get to a point that people will want to live on Venus. Like, I can imagine a research station where you've got some scientists are studying the atmosphere of Venus, and every now and then they fly off. And again, think about how you have to get away from Venus. You're in a gravity well, sucker. And now you've got to have some kind of rocket that's going to carry you out of the atmosphere. It's got the same gravity well pretty much as the Earth. And there's no ground to launch your rockets. You're going to launch your rocket from the air. So you get in your rocket, and your rocket just takes off, and it just sounds rough. It's going to be expensive and complicated, and there's no resources to be able to really change. Like, you can't you can't tunnel in the rock. You can't. Everything that you're going to have to use to survive is going to have to sent from Earth. Every single thing. There's nothing you can use on Venus except for sunlight. Everything else you're going to have to bring from Earth. So no, it's going to be brutal to try to exist on Venus. Mars will be a picnic compared to Venus. The only thing that Venus has got going is you stand out on the railing on your cloud ship, and you survey the brown and yellow sulfuric acid clouds and go, I am on Venus. Look at me. So no, I don't. I think Venus is going to suck for a long time. Space. Gravity wells are for suckers. You're going to want to live in your big O'Neill cylinder, floating at the L4 point, laughing at all those idiots who went down into gravity wells. Yeah, Matt Potter, would you need protection from the cosmic rays? Yeah, Venus has no no magnetosphere. And so, yeah, for the time that you're spending out there on the observation deck of your space station, your cloud city, you're being pelted by cosmic rays and solar radiation, just like the person on Mars. Except they can go underground like mole people, and you can't. You have to just hide under your water tanks, hoping that you don't take that much of a dose. So, no, Venus is going to be terrible. Mars is going to be terrible. Earth is the best. Like, I get that people want to go and explore the next frontier. I get it. And for a while there, I was into it too. But Earth is just so great. Trees and birds and llamas and ice and, I don't know, fish. It's got a lot going for it. Lots of people. And viruses. All right. Anyway. All right. Raimo Kangaznimi. Why not put an asteroid on orbit of Venus? Use that as a base in the long-term terraforming of the planet. That's actually a pretty good idea. That you could, well, I don't know about the long-term terraforming, but to have a base of operations be in a moon orbiting around Venus, like an asteroid that you've put into orbit around Venus, that's a pretty good idea. And in fact, we've got something like that at Mars with Phobos. So you've got the Phobos is orbiting Mars very close to the surface. It's much easier to get to Phobos and then go from Phobos down to the surface of Mars and then back up again. And so it makes a ton more sense, I think, to set up a nice base station on Phobos, use that as your gateway down to the surface of Mars. And so, unfortunately, Venus doesn't have a natural satellite, but yeah, you could sneak an asteroid into orbit around Venus and then use that as your way station. I think it would be a lot safer to hang out on a satellite orbiting Venus than to try to live in the cloud tops. Christopher Brown Floyd, is it easier to create a colony on Mercury than Venus? Yes. I would say it would be easier to survive on Mercury than it would be on Venus, because Mercury has ground and metal and probably a lot of water and other volatiles mixed into the surface. And so you could go to one of the permanently shadowed craters on Mercury. It's like the permanently shadowed craters on on the moon, and you could tunnel into the below the regolith of Mercury, and you could survive, mining all of that amazing metal. So again, you just can't underestimate how much you're going to want dirt. You're just going to want stuff to do anything, because on Mercury is everything you could need. There's going to be water. There's going to be volatiles. There's going to be metal and lots of it. There's going to be silicon, and there's going to be oxygen and all of that. And then mountains of power coming from the sun. You just have to poke your tiny little solar panel up above the edge of a crater, and you're getting an enormous amount of power coming from the sun. So yeah, no, Mercury would be far better place to go than to go to Venus. All right. It's a solid snake. Could the Great Attractor be a massive black hole? I wonder where are people wondering what the Great Attractor is at this point? How is this still a thing? The Great Attractor is just a bunch of galaxies on the other side of the Milky Way. And we are all sliding towards the gravitational well from this giant cluster of galaxies. And, you know, for all there are tons of these superclusters around the whole universe. We can see them all over the place. And every one of these, they form the anchor, the gravitational anchor of all of the galaxies and galaxy clusters that surround them. And it just so happens that of course, we're in the Milky Way. And so half of the sky through the Milky Way is going to be visible to us and half is not. And it just happens to be that the heart, the galaxy cluster, is blocked by the gas and dust of the Milky Way. But now we have very powerful infrared observatories that allow us to see through that gas and dust, and they can map out all of the galaxies in that galaxy cluster. So the Great Attractor is not a mystery anymore. It was a mystery 30 years ago, but it's not a mystery today. Neil Fraser, I thought you loved Titan. I do love Titan. Titan is the best. If you want to go somewhere, go to Titan. Titan's got a thick atmosphere that's going to protect you from radiation. It's got everything that you need as well. Well, except it doesn't have rocks. Maybe there's some rocks, but you've got all the hydrocarbons that you need. You don't have a lot of oxygen. Well, I guess you do in the water. So you've got the hydrocarbon, and you've got all the raw materials for life. It's just really cold, so bring a coat. Matt Potter, could we not build an underground base on Venus? You got to get down through the atmosphere of Venus, down, at the point where every piece of metal that you've got is where your entire spacecraft is lighting on fire. The solder, every component in your electronics is melting and frying, and then somehow dig underground. And even so, you're going to dig underground. The surface temperature is going to be really, really hot. And then as you go down through the ground, you're going to be starting to reach where the interior temperature is really hot. So I don't know if you're going to ever have a place that's cooler than the surface temperature, and it's just going to get hotter from there. So no, you wouldn't want to try to live underground on Venus. It would be deadly. Apologies. I know, you just want to fix it. You want to just fix Venus. Come on, we can fix this. Like, sometimes we just have to accept the fact that a place is terrible, and that's Venus. It's just awful. And Like, I know we want to cool it down and we want to deliver multiple comets to the surface of Venus and absorb all that carbon dioxide and return it to the green paradise. You know what's already a green paradise? Earth. All right. Raphael Dominichini, does Mercury have more resources than the moon? Absolutely. Mercury is huge. Mercury has higher density than, or would have higher density than Earth, but it doesn't have the same kind of mass as Earth, but it has more metal than Earth. And so some future civilization that is well on its way to settling the entire solar system will start dismantling Mercury to build the Dyson sphere, because it's the best place to get your resources, way better than Mars or the moon. Obviously, as we mentioned, Venus is good, but it's covered under hell, so it's hard to get at. But Mercury is going to be a lot easier. People are talking about how bad Titan is. Yeah, Titan is bad. Terraforming Ceres. Luke is saying terraforming Ceres. Would terraforming Ceres be easier? One of the things that's kind of interesting is that essentially for a world to be able to maintain an atmosphere, it has to have an escape velocity that is below 1.5 meters per second squared. So, here on Earth, the escape velocity is 9.8 meters per second squared. On Mars, it's like 5. So Mars can maintain an atmosphere. Even the moon is like 2.38. So even the moon could maintain an atmosphere. The problem is the solar wind. So if you can block the solar wind, now I want to know. That's such a good question, Luke. Hold on. Escape velocity of Ceres. 0.51. Oh, wait, that's in kilometers per second. So I don't know what it is in. Anyway, if you can get your escape velocity below 1.5 meters per second squared, then you get, then you can hold on to an atmosphere if you can block the solar wind. So that's the key. And so, yeah, you could deliver atmosphere. And so if you've got a smaller place like Ceres, then, why can't I see the escape velocity? Anyway, if you've got a smaller place like Ceres and then you need less atmosphere to make it habitable. And if you can block the solar wind with some kind of space station, then you can make a place that's actually habitable. So I think some of those bigger worlds, where is it? 0.51 kilometers per second. So does that mean that it's, that I think you need to be triple the escape velocity for it to be able to maintain an atmosphere. So, Ben Kalo, how hot can a rocky planet get? Is there a limit? I guess the limit is when the rocky planet falls into the star. So that's the limit, that's how hot. The moment your rocky planet is consumed by the star was the hottest the rocky planet can get. We're now seeing some planets that are very close to their stars, very hot, that are experiencing like rain of metal. The various metals, mercury, tin, chromium and stuff are gasified and form the atmosphere of these worlds. Winds are going 2,000 kilometers per hour. It's kind of amazing how extreme some of these planets are. So I think we're finding that what we thought, we always thought that the solar system was normal. And now we're seeing mini Neptunes and gas dwarfs and super Earths, and then there's hot Jupiters, and now there's like ultra hot Jupiters, and now it looks like there's going to be hot terrestrial planets. Yeah, Marty the Martian is mentioning lava planets. Yeah, something like that, where it's like lava. There's one place looks like it has lava 100 kilometers deep, like just like 100 kilometers of lava, and then it's covered by an atmosphere of molten metal and stuff. So no, that would suck. All right, so we've reached the end of our hour. Thank you everybody for joining me for this question show. Like I said, tomorrow, really interesting interview, another interview next week. I will post that as quickly as I can. Thank you everybody for asking all the questions. I really enjoy this. And thank you to Nancy Graziano and the rest of the moderators for managing the behind the scenes. Really appreciate it. All right, thanks everybody. And I will see you all later this week.